Advanced RISC Reduced Instruction Set Computer, Machine ARM. The Advanced RISC Machine, universally known as ARM, represents a completely different philosophy in processor design compared to the traditional x86 and x64 chips built by Intel and AMD. For a hardware technician, understanding ARM is no longer just about fixing smartphones. It is now a critical requirement for troubleshooting modern, high-performance laptops and understanding the future of mobile computing. The philosophy, RISC versus CISC. To understand ARM, you must first understand the fundamental difference in how it processes instructions. Traditional x86 processors use a complex instruction set computer, CISC architecture. This means the processor is designed to handle very complex, multi-step instructions all at once. It is incredibly powerful, but decoding those complex instructions requires a massive amount of physical silicon and generates a tremendous amount of heat. ARM utilizes a reduced instruction set computer RISC architecture. Instead of trying to process one massive, complex command, an ARM processor breaks that command down into several smaller, extremely simple instructions. Because these instructions are so simple, the processor can execute them at blinding speeds using significantly less physical hardware. The silicon pathways are shorter, the data moves faster, and the processor doesn't have to work nearly as hard to decode the software's requests. The king of efficiency and mobility. The absolute greatest advantage of the ARM architecture is its extreme energy efficiency. Because it uses a simplified instruction set and fewer transistors to do the heavy lifting, it draws a fraction of the electrical power required by a standard desktop processor. Less power draw translates directly to less heat generation. This is exactly why the processor inside your smartphone does not need a bulky metal heatsink or a loud spinning cooling fan. The ARM chip can run all day on a tiny battery while remaining completely cool to the touch. For over a decade, this made ARM the undisputed, exclusive ruler of the mobile world, powering virtually every tablet, smartphone, and smartwatch on the planet. The desktop revolution and emulation. Historically, ARM processors were considered too weak to run full desktop operating systems or heavy professional applications. However, modern engineering has completely shattered that limitation. Companies like Apple, with their M-series silicon, and Qualcomm, with their Snapdragon processors for Windows, have scaled the ARM architecture up to compete directly with high-end x86 chips. This massive shift creates a unique troubleshooting scenario for technicians: software compatibility. Because ARM and x86 speak two completely different physical machine languages, you cannot take a standard piece of x86 software and run it natively on an ARM processor. To solve this, operating systems use a translation layer or an emulator, such as Apple's Rosetta 2 or Microsoft's built-in Windows on ARM emulator. When a user double-clicks an older x86 program on a new ARM laptop, the emulator acts as an invisible, real-time translator. While this is an incredible feat of software engineering, a technician must remember that emulation always incurs a performance penalty. The application will run, but it may drain the battery faster or run slightly slower than a native ARM application, which is a critical detail to explain to a client who is upgrading their hardware.